Welcome. I'm Frank Conkling, and this is Panic Consulting's ArcGIS workshop. And with this workshop today, we're going to continue our introduction to Arcade, and this is our lesson number 3. We're going to talk about feature sets. Before we start, just to remind you that if you have interest in knowing about Panic Consulting, what we do, and hopefully have a project that we can work on and help you with it, there's a QR code at the lower right corner of the screen that'll get you to our website. There's contacts out there. There's all sorts of information about us. Please go ahead and reach out, and we're more than happy to help you. All right. So let's give a short review of where we were before. So previously, what we did is with the first lesson, first workshop, we sort of introduced Arcade. Arcade is a lightweight, secure expression language. It's for writing expressions. It's not a programming language. It's a language that's used for writing expressions. Think of this as the next generation of VB script. It's not Python. It's never intending to be. It's only for things such as mathematical calculations, formatting text, evaluating logical statements, and such. So just be aware of that. Again, this isn't full programming. This is just the next iteration of expression language. But with that, there's a lot built into this. There's built in all sorts of components on here. And last workshop, which was lesson number 2, we looked at conditionals, where in fact, we want you to do this unless this is occurring, and then we want you to do this instead. Those conditionals that's built in, including loops and what ifs and untils, those sorts of things are built into this language. And again, it's an expression language on here. So what we're going to do now, though, is talk about feature sets and what feature sets are. Before we move on, let's just another QR code, different from the previous one. This is actually a link over to ESRI's Arcade reference. And it's a really good resource if you're looking to learn Arcade, want to know more about it, especially if you're a programmer. They talk about how it compares, what it does, what it doesn't do, and how you can use all the functions in here. This actually is the reference that most of us that are looking at Arcade and trying to go and build things and work with Arcade, this is where we go. We look to here. All right, so let's go to this. What is a feature set? So a feature set in Arcade is a way to go and pull information from a separate layer. Let's use that old terminology, that it's a separate layer. It can be a feature class in a geodatabase. It can be a feature service in a website. But basically what it's doing is it's looking at ways to go and collect the information from a separate data source rather than the one you're actually working in. If you remember previously, we could always work with the individual attributes of the features that we had selected. And we did that. We would do things like calculate acreage and go and populate certain attributes on here. Well, this is the next step. This is, okay, well, how do I get information about a layer that's not part of where I'm at right now? And there are multiple feature sets. There's multiple ways that we can reference that feature set. We're really only going to pay attention today to the one that's most commonly used, which is feature set by name, in which you actually go and reference it. But just be aware, there's also a feature set by relationship name. So that if I have a feature class that has a relationship class built up, in other words, these features have relationships over to another layer, you can actually use that relationship name to reference that other feature service, that other feature set. The other one is a feature set by association. The association is actually built into the utility management solution. It's not the parcel fabric, it's the utility management solution. There's also a way to reference a feature set by being a feature set by portal item in which you've got an item stored out on a portal, a web portal. If you know that item's reference, you can go and click on that. Or finally, if you have an ID inside of a web map, you can call out a feature set by ID. So there's all sorts of ways to get to feature sets, but we're only going to talk about the first one. By the way, before we go any further, I just want to stop here. For those of you that are attending in person, please use the chat window for any comments or any questions, anything. Chris with Panda is working that, and he's moderating it at the moment. So if you have any questions or any comments, go ahead and put them over there, and he'll go and he'll either answer them or he'll interrupt me, and we'll make sure that we get your comments and your questions answered in here. All right, so what we're going to do today is just look at a couple different examples, and we'll take time and actually review each of those examples and show you how it works so that you can get a better understanding of how to use feature sets and sort of the types of code that might be involved in here. This first one is a very, very simple one in which we have a feature set that's being referenced by name. And basically, we want to do a simple intersection of a polygon on top of another polygon feature class, but we're not looking to calculate the acreage or any of the geometry. We just want to pull attribution out of there. So what we're going to do is we're going to use the centroid of our current feature and drill down into another layer and pull attributes out of there. So this is the code that we're going to use. And I'll actually, once we get through this code, I'll actually show you how this actually works on here. All right, so again, if you remember this first component up here with these double slashes, this is actually just a comment. It just says, get the subdivision name from a subdivision polygon layer. The next one is we set up a variable called feature set map index, and it's defined as being a feature set by name. And then we're using the global variable of $data store. Now remember, there's two variables that global variables we could use: $data store, which means it's in the same geodatabase, or $map if it's a web map, in which it means it's in the same map. And then we're putting a comma there. We're then giving it the parameter of what feature class are we pulling it from. In this case, this is the simultaneous conveyance feature class, our subdivisions, and then a comma, and then the parameter of what attribute field are we going to pull. We're going to pull the convey name attribute field, and we put those in brackets as you see. So that's the first one here. Next variable is being defined as being an intersect map, in which we're actually going to go and intersect the two. And what we're using is we're using the within, meaning look for the centroid or look for the polygon that the centroid is within. So we're going to use the map index as defined here. We're going to define and use the centroid of our feature. And again, there's our feature. There's the centroid. We're going to find out what polygon it's within inside of that feature service, inside that feature set. Okay. Next thing we're going to do is define another variable called map index, and we're going to look for the first one because it's possible that we might have overlapping polygons on here. In this case, we're not going to do a whole lot of checking as far as multiples. We're just going to say, get the first one that you've got on here. And we're going to take that first one out of our intersect map variable. And that's going to be the subdivision that we're going to pull that attribute out of. We are going to have a little bit of error checking here in that we're going to say, okay, if the map index is equal to, that's what the double equal sign is equal to null, meaning we don't find anything. Just return an error and say, hey, no subdivision was found. Boom. And then this return basically says, just don't do anything, just pull out of here. And then the next error check is going to say, if in fact the convey name, the subdivision name is empty, just go and do the same thing and give us an error saying the subdivision name field is empty. Otherwise, if these other two are not valid, go ahead and just return to us the convey name. So let's go and see how we actually would use this on here. So here's where I'm going to use it. I'm actually going to create an attribute rule so that my conveyance division polygons, my lot polygons inside the subdivisions, they will capture the subdivision name in which they are located. So what I'm going to do is I'm going to go and create a new attribute rule here. And on this attribute rule, I'm going to call it capture sub. And I'm going to tell it to go ahead and store this in that name. So I'm going to take and I'm going to have this attribute rule go and populate it, and whatever the results are, it's going to store it in that name. Then what I'm going to do is I'm going to go in here and I'm going to add my arcade rules. Now I've actually cheated and I've got all of my workshops in here. It's my soils intersect. Let's see if I have that in here. Soils intersect. This is an older one. I don't think I'm going to use this one, but this one is a buffer one. This is another type of soils in here. Oh, I know what happened. I had done an expression. Let me cheat again and capture that. Sorry about this. Let me go and do this. Let's tell this if I'm going to go and calculate a field. Interestingly, there's two different ways that the arcade information is stored. One is in an LXP file and one is in an EXP file. One is an expression file, one is a label. So let's go in down here and let's look in that same area in the workshop, and here's the Centroid one. All right, go and open that up and let's capture that. All right. So let's go back here and go back and load that code in. All right, just to make sure it is the same code on here. Again, get the subname from the subdivision polygon. Here's all those variables. Let me go and validate this code. And it says that the expression is valid. All right, so I can go ahead and make the assumption. As a hint, always validate your arcade code. And I'm going to tell it to do this when I first create my polygon. I could also, again, with an attribute rule, remember, I could also go and tell it anytime I change my polygon, change it by either changing an attribute or changing the geometry of it, go ahead and update it. I don't need to do that for this. I just want to go and tell it the first time I create it, go ahead and store that. And once we go and store this in our geodatabase and it becomes active, we'll go ahead and create this just to show you what it looks like. All right, I don't see any questions yet, Christopher.
None yet.
Okay, thank you. And again, if you need a reference as far as attribute rules and how they work, we have some videos on the YouTube channel. Just look up attribute rules and we'll show you a little bit more about it. Remember, arcade can be used in attribute rules and labeling and calculations and all over inside of Esri's products. So what we're going to do is we're going to go and create a couple things. I'm going to go ahead and create a new subdivision. All right, so this is a subdivision. All right, I'll create a subdivision and I'll attribute it just so that we can see what this actually is. Workshop is the name of this this subdivision. I really don't even need to do that. So there's my subdivision. And if I were to go and label it, you could see that, in fact, make sure that it's labeling correctly. On here, which one is it? This one. Anyway, this does have the expression on there. Come on. I want the expression. I just want the label name. Thank you. Thank you. Workshop. So I do have an expression on there now, and it is a label on there. So it is called workshop. Now what I'm going to do is I'm going to go in there and I'm going to create lots on here. All right. I want to create a conveyance division lot on here. And as I do this, it will automatically go and capture the name of the subdivision in which it's located automatically without me going and doing anything else. So the code actually went and ran. But what it did is it created a centroid, and then it drilled down into the feature set that's defined as being the simultaneous conveyances. And then when it did that, it went and captured that value that's stored in that other field. So what happens if I go and create a lot over here? All right, and I create it, and it's going to go and tell me on here, oh, wait a minute. It's not inside of a parcel. It's not inside of a subdivision. So it won't let me do that. What happens, however, because of that error checking? So what happens if I have a lot where the centroid is not there? Won't let me do it. But if I have one where the centroid is there, it will do it again. So one of the things you want to be aware of is in using that attribute rule that says, you know, that it's looking to go and determine whether or not the centroid is within here, and especially the error checking. Just recognize that it's using this centroid geometry to figure out whether or not it's inside, and then determining whether or not it's going to allow you to proceed or whether it's going to give you an error message on here. All right.
Frank,
yes.
There is a question in the chat.
Okay.
Is there any way to trigger the execution of an attribute rule from the UI instead of just when some type of event happens, like, you know, creating a feature?
Unfortunately, because the attribute rule is again, it's an expression language, you can do it through a calculation function, but it's not something that you can put a button on and say, go and execute this. It can work, for example, and I'll go and show you here in a minute. If I go in here and I go and if I modify that attribute rule to be on a, not just the insert, but also an update, a way that you could do this is tell it to go and let's do this. Let's go ahead and explore this a little bit further. If we go to attribute rules here, and I go to this attribute rule and I say, well, don't just do it on here, but also do it on the update component on here. All right, and let's go ahead and let's save that out. And let's save this attribute rule. So you can't do it with a button, but you can do it so that if you have the update trigger set, when I go and do an update on that. And that can be an update of the geometry, or it can be an update on any attributes on here. You can do that. So, Mark, I see you have a comment down here. Thank you. And thank you for attending today, Mark. Mark just said you can run arcade code to perform calculations within the attribute table. So again, if you update an attribute, it will run it, or inside a model builder. Thank you. I wasn't aware you could do it in model builder. Is there a certain feature or analysis you have to do that, or is it just a calculation, Mark? Attribute rules are the triggers that call the attribute code. Thank you. So let's go in and show you how you might do this on here. So if I go in here and I go and select the subdivision and I modify this subdivision. Okay, so instead of being workshop, I can call this demo. All right, when I do demo, it changes that. Notice my individual lots. They're still holding this one here. But if I change an attribute, here, such as making this a different type or change a name on it, let's go and change a name on here. If I put a name on here, note what happens to the subdivision or condominium name or condo name. It automatically went and updated on there. It automatically updated. So it's the triggers that have to be executed. Once they go off, then it will re-execute the code on here. But it only executed on the code on which I actually made a change. So on this one here, it still says workshop, is it? But I can go and anytime I go and make a change on here, and it'll do the same thing. It'll automatically execute and do the analysis against that feature set to figure out, oh, let me update my attributes by rerunning that execute or rerunning that arcade code. Thanks. So you can't necessarily put an interface element in here and do this, but you can trigger it off of an update in an attribute table, either through the attribute pane or the attribute table, or by going and, as Mark just showed me, you can do it in a model builder. By the way, I'm glad Mark is here. Mark, I'm going to actually use some of your code on the last example that I'm doing here. So again, this is the first example. This is one in which we're going and creating a feature set by name. We're telling it that that feature set is in our geodatabase and it is named conveyance division, and we're going to pull the value out of the convey name. And then we're going through here and we're going to go and capture that and put it into our lot file on here. So yeah, I see burn. The point of the question was for updating all features within the attribute rule was added to an existing feature class that already has stuff in it. Yes, you can do that. I actually have a really good video on that. I think I did it last month, in which I talked about the local government information model and the parcel fabric, in which I told it to go and execute attribute rules, both pulling in information from a record into all the features that are associated with that record, or pushing them when a change has occurred back the other way. So yeah, that you can go and do that. It's a good question. Any other questions on that first one, which is basically intersecting with a centroid? You just want to be aware that that's a really simple rule, but you want to be aware that it's using the centroid to calculate that. And if you go and draw it a little bit off so that the centroid isn't there, you're going to get error messages on there. Okay. The next example that we're going to do here is an intersect point to a line. And what we're going to do here is that we're going to go and insert a point and have it go and take and go and find the closest line and then pull a couple of values out of that line, out of that attribute field, and then use those to populate another field. All right, so the code, we're actually setting up a buffer, so it's going to look for within 10 feet of the feature that we actually select, that we actually input, that point we put on there. Then we're going to go and create another intersect layer, and we're going to use a feature set by name. It's going to be called tax lines, and we're going to pull two attributes out of there. We're going to put the distance field, and we're going to pull the arc length field out of there, and we're going to use a buffer against it. Again, that's that 10-foot buffer, so we find a line. We don't have to be on it. And what that's going to do is tell us then, using this another variable called int count, it's going to tell us how many lines we intersected, and it's going to initially set the expression to blank. Then it's going to look and it says, if it's 0, go ahead and don't do anything, set that to null and get out of there. Otherwise, go through and iterate through and look to see, and this is that conditional statement that we talked about the last time. If the arc length field is empty, use the distance field. If it's not empty, use the arc length field. Now remember, on a curve or on a straight line, if it's a curved line, you'll have a value stored in the arc length field if it's COGO. But if it's a straight line, you won't. So all this is doing is checking to see whether it's a curve or not by looking to see if there's a value in the arc length. And then it's going to go and put it in here, and it's going to go and add it, add that attribute value, round it to 2 decimal places, which is what this is here. Then it's going to add a dash afterwards and return it. Let's go and look at this. So I think I've got this set up already. Yeah, I do. And this is in an attribute rule for a point feature class. All right, again, this is what we're going to do. We're going to buffer it by 10 feet. We're going to go and call up the tax lines, and we're going to capture the distance value and the arc length value out of there. And this is the buffer of the 10 feet. Then we're going to go and iterate through and find it and say, okay, if the arc length is empty, go ahead and use the distance field. Otherwise, use the arc length field. All right, simple enough, but it's pretty amazing what it does. So I've got this labeling right now just to show you, and these are COGO lines. We can turn these off and turn these off and make it a little bit easier for you to see. And what I'm going to do is I'm going to create now. I'm going to turn on my label points. I'm going to create a label point. Now, as I click next to a point, it's going to look to see, it's going to go and find a line that's within 10 feet and go and capture that COGO value and then put it and insert it in my attributes. In this case, it's attributing an attribute field called text string. It's going to populate that and use that for labeling. So if I go over here and see, there it is there. Now I haven't set angle on here or anything, so everything's coming out, vertically, but just to go and show you, it's going to pull that value out of there and use that for the label. Now I purposely have a line here that's not actually been calculated correctly. It has COGO values in there, so if I click here, it'll show you there's the COGO value that's stored on that line, but this line on the north side of the right-of-way has not been split. It's still going to return that value on here. But this simple little expression here allows us to go and every time we insert a point, it will go and buffer that out and look for a line. So previously we were looking polygon on polygon. This time we're going to look at point against line. So we're going to do the analysis against it. By the way, just to show you how this also works, because we're only looking at the tax lines, I can have my simultaneous line on, I can have my conveyance division line on here, and it will only go and show me what's on the tax lines. It's only going to analyze the tax lines on there. All right. So any other comments or questions? I see Mark actually put something up. Attribute rules call attribute code upon geometry code. Model builder calls code with geoprocessing. Okay, field calculate calls. Yep. So that's the trigger as you go and do a field calculation against it, and it will call up the arcade code that's stored against that feature class that's stored inside the attributes. Yep. Thank you, Mark. Good choice. So this was actually pretty interesting because inside of the parcel fabric and inside of feature services, the feature services don't like annotation. A lot of us don't like annotation, but they don't like annotation. And what a lot of our clients are doing is they're asking to replace the annotation with label points. And we're using points feature class to go and represent the location of those label points. And we set up some arcade rules that capture things such as the COGO values, whether it's a curve or not a curve, and then also populate that. And then we're also using arcade or using attribute rules to go and capture the actual angular rotation so it follows the line on there. You can use arcade in a lot of different ways here. Any questions on this? Really, the more you get into this, the more you realize it's very, very powerful to go and do this. So this next one, and this is the final one we're going to go, but I want to spend some time on this one. And I'm going to give a shout out to Mark, who's in here right now. Mark Falls is GISP. He's up at Lyon County, Minnesota, GIS coordinator. Mark took my primitive code, and it was primitive. It worked, but it was primitive. And he updated it, and he did a really good job on this, in which when I click on something, well, let me show you. Before we talk about more of it, let me show you. So on here, I've gone and taken and assigned this to my tax parcels, and I've assigned it so that it goes, and when I click on a tax parcel, the pop-up is going to go and perform something. So remember, pop-ups are over on the map, and I can tell it here. So when I click on this, now right now, I don't have a pop-up because I've disabled my pop-ups. And I've said no pop-ups. But, okay. So on here, oh, I disabled my pop-ups here. I want to enable the pop-ups. So when I click on this now, it's going to go and do an analysis, and it's going to tell me not just the name of the parcel, but it's actually going and doing an intersection using feature sets, and it's calculating the total acreage of the parcel, the total area, number of soils in here, the 3 different types of soils, and giving me a summation on all of them. All right, so one of the interesting things about feature sets is that I don't even have to have my soils on. I do have my soils inside of here. So I do have a soils feature class that's called from the data set, but it does not have to be turned on. It only has to be available for that feature set to go and comply with the Intersect. So let's go and look at configure of the pop-up. All right. And I know I'm calling you out quickly. Mark, do you want to go in and tell us about this and explain the code, or do you want me to go and do it? Okay. Mark said that I can. All right. So let's start with a couple things. Inside of a pop-up, in order to have arcade code run, you go and you create an expression, and it's an arcade expression. And what that expression will do is it will go and execute anytime you click on a pop-up on here. And this is a great use of arcade and feature sets, is allows you to go and do this. So again, this is arcade code, and this is marked code. And basically it's just listing the soil types by soils in a parcel by type and acreage. And first getting the features from a soil layer that's overlapped by the parcel layer. And again, setting up a variable, setting up the intersect. So it's going to intersect the feature set by name that's stored in a data set. And a feature set is called soils. And we're going to intersect it by this feature. Then it's going to go and create a dictionary. Now, this is part of the advanced component because that dictionary allows Mark to go and iterate through and calculate the total acreage and such. So it's going to create a dictionary of the soil areas, and it's going to create a variable that's going to store the sum of all the soil types. And then he's also going to set a variable to hold the total amount of acreage within the selected ones. And then he goes and loops through this. All right. For each of the variable S's, and again, S is the soil types inside of here, inside of that intersection. Okay. He's going to go and build it up and calculate the acreage on here. That's what this area, the intersective feature on here, and he's going to add that to the sum. And then he's going to go and accumulate it or aggregate it. Then he's going to look at the month code on here. It's going to go and use it and aggregate those, figure out how many are in here, and then he's going to go and give out the results. And here's sort of the what he's actually going to say on here. What's going to be pulled in here. It's going to say here, this is what it's going to say, and it's going to loop through these and calculate the overall percentage on here and return this. Really nice code. Mine was very primitive. Nice additions to this, Mark. I know I didn't do it justice, but so let's go in and just sort of take this and we will look at feature layer, and let's make it some 80% transparent, and so that it doesn't overpower. And you can at least see there's multiple things in here. And then as we go and again use the explore, and we're going against it, it's telling us that this parcel, all right, is less than an acre. It's only got one type on here. It's that. Let's go over at this one here. It's got two types. Here's the two different types, and here's the names of them. Here's the percentage of the acreage within them. All right. Here's another one. Again, in this case, it's going and giving you that specific component on here. It's filling out. This is not pre-analyzed. This is not doing a union. This is one of the real beauties of arcade, and the fact that it can do these intersections on the fly. And really one of the best things about this is that not only does it work inside of ArcGIS Pro, it works on a web map, so that you can set up a web map with the arcade and actually have it go and do the intersection against all the layers inside your web map and tell it what soils it's on, what the flood zones are, what jurisdictional areas, what school zone it's in. You can do that on all of it. Matter of fact, one of my favorite things to show is, again, let's go in here. Let me go in. You can tell on this, this is on the fly right now. I'm going to go and show you something that was done up in Tallahassee. And this is the application. Let's go ahead and do this. So with this application, what this is actually doing is taking this concept of having a feature set and having the pop-up go and intersect through multiple layers on here. And it's actually intersecting through a whole series of layers to do things such as give you the location, the address, parcel ID, area, the subdivision in which it's located, the jurisdiction in which it's located, whether or not the zoning is. So what's the zoning on here? What's the future land use? Is it inside a specific overlays? Or is there an overlay here or not overlay on here? What about economic incentive areas? Is it inside the economic incentive area or not? Is it in a FEMA flood zone? What zone is it in? What about public schools? What's the public schools as far as the school zones that parcel is going through? And it's going through and giving you all of those links. And to show you what that actually is doing, I'm just going to call up the actual web map that's coming from to show you. Let's do this in Classic. Look at the web map and actually go and use this to show how this actually works. All right. So it's a base map in here. Then on top of the base map, you'll see all the layers are turned off except for parcels. All the other layers, the school zones, subdivision boundaries, and in the layers, if I go to configure pop-ups here, you'll actually see that I have all of these different expressions on here. All these different
Frank,
expressions. Yes.
when you have a moment, there is a question in the chat.
Okay.
Do you want me to read it to you, or do you see it?
Sure. No, it says, how does this handle something with multiple values if I have multiple address points in here? So it's a really good question, Matt. So the reality is, if you think you're going to have multiple ones, think about it the same way that we did with the soil. Have it go through and do an intersect of the polygon against the points and let it collect all of the points and then give you a list of those address points inside of that one polygon. It's just the code gets changed a little bit. Instead of doing a comparison against a polygon feature class, you're doing it against a point feature class and then going and running through doing that same iteration to show you what how many addresses are in there, and you list them out on here. Okay. Yeah, it's a good question. It's possible that's one of the early things that some of the arcade developers were using to illustrate this. So in here again, I got another comment asserting the data store refers to data workspace that contains the feature class attribute that the rule applies to. What other happens when you refer to other layers like the soils in a different data set or workspace, since all the layers in a map don't have to come from the same data source? Look at that. Okay, so let's go and look at this actual code that's in this web map. Okay, let's look at this, and it's actually inserting in here. And I wish, so if I look at it, intersect layers, and what it's doing is it's intersecting not the data store. It's intersecting the map. The map, if you're in a web map, it doesn't have to come from the same database. It can come from multiple places to go and do this intersection. All right. It can come from multiple places. It doesn't have to be stored in the same data set. So you could have it intersect layers that are stored in your map. I say stored in your map, that are being displayed in your map without them actually being part of your data structure. That's what this is. This is out on a web map. It's actually looking at resources coming in from all over on the internet, and it's doing intersections against them and calculating all of these values on here and saying whether or not it's present or not on here. So for example, this flood zone, if I look at this FEMA flood zone, it is still doing it against the map, so it's in part of the map, but it could have also been a feature set, not by name, but you could have done a feature set by ID, or it could have been a feature set by portal item, if in fact this was on premises on your portal. There's a lot of ways of referencing these feature sets besides just a name. A name is the easiest way to do it. But yes, the beauty is it doesn't have to even be your data that you're referencing. I've got a client that has parcels on here and on his on a web map that their internal appraisers are looking at. They're looking at a timber analysis, and he's looking at all the timber located within a certain area. And as he has new parcels, the appraisers can click on a parcel and say, what's the acreage of timber that's active timber on this as a result of this? So yes, the feature sets actually go and open up an entire world of ways in which you can go and do these types of analysis on here. And again, this is one of the best examples here, is it has all of these in my map or in this map, but it only turns one of them on. It has the base map and that, and everything else is turned off. And then now when I go and zoom over to a layer somewhere, to a parcel, and I click on a parcel, it automatically goes and the arcade script goes through and pulls information from each of them. It pulls the address, pulls the parcel ID, pulls the acreage, whether or not it's in a subdivision, whether it's recorded, what's the jurisdiction, whether or not there's an assessed use on here, and then all of the land use information. Intersects, this is, this is really the power of Arcade, the power of the new Esri technology. This is the reason why those of you that are still on ArcMap, please get off. Transition over to Pro and the newer technology. It's well worth it. All right, so let's see where we're at. So by the way, Mark, I hope you don't mind this, but Mark's code, I'm actually making available. There's a QR code here. You can download that one code. If you wanted to, you actually could have typed in all the stuff that I did, but hopefully, Mark, you haven't got a problem with that. So there's the code. Are there any other questions on this? Again, you can tell how excited I am about Arcade and all the things you can do with it, and feature sets, and how you can really use feature sets to go and take Arcade up another level.
No questions in the chat.
No questions. All right. Well, thank everyone for coming, and hopefully you enjoyed it. Please feel free to attend others, and we're going to stop the recording. Thanks for attending, and we hope you enjoyed this workshop. If you have questions, would like some more details about anything we discussed during this workshop, or if you or anyone at your organization would like information about training, support, or ways in which we can help you with your GIS needs, please contact me at frank@pandaconsulting.com or call me at 561-691-3277, and we can discuss how we can help you with your needs.